Have astronomers found the first signs of life on an exoplanet? So much James Webb news, the closest black hole to Earth, and NASA gives its report on UAPs. All this and more in this week's Space Bites. All right, buckle up. We've got a lot of James Webb Space Telescope news this week. First up, astronomers have found the first example they think of a Hycean world. The planet is located about 120 light years away from us. This is a planet that is several times the radius of Earth, with a thick hydrogen atmosphere and probably a thick liquid ocean, like an ocean that could extend for hundreds of kilometers deep. And using James Webb, astronomers were able to analyze the atmosphere of this planet, and they were able to determine that it has methane in the atmosphere. They were able to detect carbon dioxide. And so from all of these clues, they're suspecting that it is one of these Hycean worlds. It's a portmanteau, hydrogen ocean, Hycean. So that's the news. We've seen an exoplanet able to measure the atmosphere, found methane, carbon dioxide, could be one of this really interesting class of planets. And what's great about these Hycean worlds is that they could have liquid oceans in temperature regimes that you wouldn't expect. And so they could be in a very much colder place or a warmer place and still have a liquid ocean on the surface that hasn't boiled away. You could have a rogue planet that's drifting in the cosmos that isn't orbiting around a star. But yet, if you get that thick hydrogen atmosphere, you could have liquid water on the surface of this world, even though it's not near a star. So it really kind of expands the possibilities for what's out there. And they're theorized, so maybe this is the first example. But the less certain news that I'm sure you're going to hear a lot of is that astronomers think they might have also detected a biosignature in the atmosphere of this world. Now, the gas that they're detecting is called dimethyl sulfide, or DMS. And we have this chemical in the atmosphere of Earth, and it comes almost entirely from photosynthesis, from phytoplankton. So have astronomers detected life on another world? Well, not so fast. So the first thing is that the quality of the data isn't great. Astronomers say they have a 2 sigma detection of this dimethyl sulfide. So that is like 98% sure that this stuff is there, which is, you know, like that seems reasonably certain. And yet for scientists, that doesn't even qualify. They want 5 sigma. They want 99.99994% certain that a gas is there for them to really be convinced. Scientists are never happy. And then the second problem is that there may not be such a thing as a biosignature gas that you could find, that every potential kind of chemical that could be found in the atmosphere of a planet that could be produced by life could also be produced by some non-biological activity. So methane, you can get methane from volcanoes. You can get methane from cow burps. You can get carbon dioxide from plants. You can get carbon dioxide from volcanoes. There are various processes that can happen between the interface with the ocean and the atmosphere and rocks that can produce these kinds of chemicals. And so astronomers still argue, and really, if you ask astrobiologists, like, is there one chemical that if you saw that, you would say there's a 100% chance of life there? They say no. That they still haven't worked out any kind of chemical that must have come from life. And so it's going to be more complicated, once again, than anyone ever expected. And so you're going to have to put together a whole bunch of clues together. You may have to see the presence of oxygen in the atmosphere, and maybe ozone, and maybe also methane, and maybe also this dimethyl sulfide, and maybe you also have to be able to detect the red edge in infrared, and maybe you also have to be able to see the cities and the chlorofluorocarbons and see the spaceships flying. Like at a certain point, the evidence will be overwhelming, but there will always be a lot of uncertain evidence, and so we're going to live in this gray area for a long time. So don't get too excited. But get excited about the fact that we might have seen a Hycean world and that Webb is continuing to analyze the atmospheres of these exoplanets. Another James Webb picture of a protostar. I'm not gonna lie, I kind of chose this story this week because it is one of the coolest pictures that have come out of JWST that I've seen in a while. And I know we're still probably 9 months away from when we start our voting for the year 2 top photos, but this is going to be on the list, I think. You're looking at an example of a Herbig-Haro object, 211 to be specific. And what these are is the region around a class 0 protostar. And class 0 protostars are stars that are just a few tens of thousands of years old. They're still in the process of accumulating material. And the one that you're seeing only has about 8% the mass of the sun, and yet it's expected to eventually become a star like the sun. And so it's pulling in gas and dust to build a accretion disk around the star, and yet it's already starting to form these magnetic field lines that are throwing some of this material out into space along these polar jets. You can see some of this material as it's illuminated, but what you can't see is all of that darker material that is swirling in. That's why regions of this image look very dark. And it just goes to show, like, we can see stars at every single stage of formation, from ones that have just begun to ones that are newly formed to ones that are dying and ones that have died. And so, we obviously haven't lived long enough to watch any one star go through the entire stellar formation process, but we can see each one of these phases in different examples. What's going to come after JWST? Now, I've been reporting a lot on the kinds of telescopes that will come after JWST. And until recently, astronomers had 4 different telescopes that they were imagining. There was HabEx, which would be designed to find habitable exoplanets. There was the Origin Space Telescope, which would search for the first stars in the universe. There was LUVOIR, which would be a true successor to the Hubble Space Telescope. And then there was LYNX, which would be a next generation X-ray space telescope. And then in 2020, scientists came together for their decadal survey. This is something they do every 10 years, where they meet and figure out what are their priorities in science for the coming decades. And they know they wanted a next generation telescope to come after the Hubble Space Telescope, something that can do the same kind of work that Hubble does, but better. But at the same time, they were aware of all of the cost overruns and the long time delays that came with the James Webb Space Telescope. So they don't want to fall into that mistake again. And so the new plan is the Habitable Worlds Observatory. And this is going to be a telescope that will probably be the same size as James Webb, 6.5 meters, but it will be in the near infrared, visible, ultraviolet. And then the bonus is that it will be equipped with this separate spacecraft, a star shield that will fly in front of the star that the telescope is trying to observe, and then it'll block the light from the star, but just let in enough light so that you can see the exoplanets that are orbiting around it. It's expected that this will be able to analyze probably 24 Earth-sized worlds orbiting around sun-like stars in the habitable zone, so other Earths. And now NASA has organized a meeting for 56 different scientists and experts to come together and start to plan out what will be the science objectives of the Habitable Worlds Observatory. What are some of the key technological challenges, the risks? What are some of the compromises that might have to be made? Like, they're beginning the design process of this telescope. That all sounds really exciting, but it's expected that this probably won't fly until the end of the 2030s or maybe into the 2040s. So it's going to be a long wait, but I will keep you posted for every single incremental change as we go along. What is the closest black hole to Earth? The problem with black holes is that they absorb all of the light that falls into them, and so they're really tricky to find. In fact, the only black holes that astronomers have been able to find is through their interactions with other stars. So you've got a black hole in a binary star system with another star, then you can see the star wobbling back and forth, and you can infer that the black hole is there. The closest known black hole is about 1,500 light years, and it was found in Gaia data. But that's probably not the closest black hole. It's sort of like, you're always close to a spider, right? You're always close to a black hole. The closest black hole is probably inside a star cluster, a place where you had a lot of stars of varying sizes, massive ones, less massive ones. The most massive ones exploded to supernova, collapsed into black holes, and they're still lurking around inside the cluster. Now, the closest cluster to Earth is called the Hyades cluster, and it's about 150 light years away. So it's very close. You can see it. You can see it with your eyes. You can see it in a small telescope. It's in the constellation of Taurus. Astronomers wanted to know if there were black holes inside the Hyades cluster. And so what they did was they measured the movements of the stars, both near the core of the cluster as well as near the outskirts of the cluster. And they modeled what those stellar movements would be like if there was no black holes in the cluster or if there were more. And the movement of the stars in the cluster roughly match 2 to 3 black holes in the cluster as well that are influencing the movement. So the closest black holes to Earth are probably about 150 light years away, which is still really far away. So don't panic. That's not close. It's not a risk to us, but it's nice to know where your enemies are. Every week, we do a vote on our channel where you tell us what you thought was the best story of the week. And this week was a bit of a surprise. The top vote was for the upcoming launch of Starship. Now, I didn't say Starship was going to launch. I didn't give you a launch date, but like just the hope that this thing is going to fly, finally, I think everyone's pretty excited about. So I have no updates on whether or not it's going to fly. We're still waiting for FAA approval. So it's still an unknown number of time. Could be now. It could be sometime around the end of the universe. Now, if you want to participate in this vote, you can just see it on our channel page. But if you subscribe and you're active on our channel, then you have much higher likelihood to see when these votes come through, and then you can contribute and help give us that feedback. And of course, participate in our annual photo roundup from JWST. So make sure you subscribe to the channel and then like stuff occasionally and make comments, and I'll reply back, and it's a lot of fun. And you'll be able to see these votes as they come through on your phone or computer. The effect from DART's impact was long lasting. You, of course, remember NASA's DART mission, the Double Asteroid Redirection Test, where they smashed a spacecraft into asteroid Dimorphos, which is the moon of asteroid Didymos. Astronomers did follow-on observations with a range of telescopes, including the Hubble Space Telescope, and they found that the orbital time of Dimorphos had decreased by 33 minutes. So force equals mass times acceleration. You smash the spacecraft in, you get an equal and opposite reaction, and you get the asteroid's orbit slowing down. Fine, that's what you'd expect. And then astronomers were able to measure debris coming off of the asteroid into space, and they could see swirls and eddies as the solar wind was picking this up and starting to blow it away. But then, a month later, astronomers did more observations and measured the time that it took for Dimorphos to go around Didymos, and they found that it had slowed down even more, so that now it was 34 minutes. So it had added an additional minute a month after the original impact. And this doesn't make any sense. Astronomers have no idea what kind of mechanism might be causing this additional orbital time. The impact happened, a bunch of debris was thrown off into space, that caused the slowdown in the orbit, but then nothing else should be happening. Obviously, one possibility is that it's a measurement mistake, and so more measurements will maybe fine-tune this, but the astronomers are pretty confident that they got that measurement right. So what could be causing this? Well, one possibility is there's some kind of outgassing, but astronomers didn't see any outgassing. Another possibility is that there was some kind of ongoing gravitational effect that was coming from the material that was thrown off into space that was changing the movement slowly over time. But that's weird, and it shouldn't, it's orders of magnitude larger than what you would expect. And then one more intriguing possibility is that there was already some level of variability in Dimorphos' orbit around Didymos, and so this is just part of the process. So more data is required, and fortunately, the European Space Agency is sending a follow-on mission to Dimorphos called Hera, and so it's going to make ongoing long-term observations of the two asteroids and try and help astronomers get to the bottom of this mystery. Astronomers see dark matter blobs just 30,000 light years across. I hope you enjoyed this week's interview with Dr. Ethan Siegel. There's a bunch of stuff that you didn't see where we were sort of warming up and talking about what we wanted to chat about, and then sort of some follow-on chat that we had. And one of the things that Ethan brought up was a bunch of new results that had come up about the resolution of dark matter. And I guess we didn't get around to it in the conversation, but he said there's a bunch of new findings that were coming very soon, and they're out. So astronomers have been using gravitational lensing to observe the dark matter surrounding a giant galaxy cluster. So what they do is they look at this giant galaxy cluster, and it is lensing a background galaxy that is about 11 billion light years away. And then the light is coming from this background galaxy. It's passing through the region around the galaxy cluster, and then it's kind of warping and changing as it moves through this region. And they were able to measure these gravitational lensing effects with such precision that they're able to actually start to map out blobs of dark matter in the region. And they're able to observe blobs down to about 30,000 light years across. And so when you think about like the size of the Milky Way, we're about 120,000 light years across. You could like fit 4 of these blobs side to side to cover the Milky Way. So they're very big still. But nobody has ever been able to bring the resolution of them down to this point. I want to give you an analogy, right? Which is that you're like, imagine you're down at the bottom of a pool and you're looking up and you're seeing the distortion of objects, like maybe a tree or something that's outside the pool. And then you're able to sort of see just the overall presence. That tells you that the water is there. But now you would be able to, by watching how the tree is getting distorted, you would be able to know that the waves on the top of the pool are of a certain size. And that's kind of what this discovery is made. And there was like another paper that came out at the same time. And our story on Universe Today, we kind of put these together, but you're now getting to the point where astronomers are now mapping dark matter into smaller and smaller pieces, which hopefully will give us some kind of clues about what's going on. Again, no idea what it is, just mapping its existence at finer and finer resolution. NASA releases its UAP report. There's been a lot of interest in UFOs recently, or UAPs, unidentified aerial phenomena. And there's of course been a military inquiry into this, and there was also a NASA inquiry into this. And the group behind the inquiry from NASA have come back and delivered their first report. And you're going to be surprised to find they didn't find any evidence that any of the UAPs seen so far have come from an extraterrestrial origin. So there's no proof that UAPs are aliens. They were able to explain a whole bunch of the objects that were previously unexplained. They were able to see aircraft, see their contrails, be able to recognize weather balloons, Starlink constellations, things like that. And then there was still a bunch that they weren't able to identify, mostly just because the data wasn't great. So they couldn't just untangle what was going on in the picture or the data to be able to say conclusively what this thing is. So it just has to remain unidentified, like it's right there in the name. But what they really suggested was ways this process could be improved, that there could be more transparency between different groups, that there should be ways that the public can post any interesting data that they've discovered. You know, everyone's carrying a smartphone, so if you see something, share it. And then better instruments and technology to be able to try and identify what these things are. They even recommended some existing or planned satellite networks that could be used to assist in this search. They mentioned in the report that pilots and people in the airline industry report 100,000 UAPs a year. Like, that's a lot of data to go through. They also announced that they're going to be having a new director to lead this working group, but they didn't mention the name of the director or like what the budget of the group is going to be. And the reason was because of the safety of the panelists. So apparently the panelists have been getting threats. That does not surprise me that people are getting threats because they're doing this work. I mean, I get threats on my YouTube channel for not reporting enough about UAPs. So it doesn't surprise me that NASA is getting this as well. So like, that sucks. Anyway, I'm going to rant about this more at the end of this episode, so stay tuned if you want to try to hear my position on this. But let's continue on with the news. But first, a promotion. I want to recommend that you subscribe to my weekly email newsletter. Now, this is a newsletter that I send out to almost 70,000 people. I send it out every Friday. I write every word in the entire newsletter. There's no ads in the newsletter. It's completely free, and you can subscribe to it. Go to universetoday.com/newsletter. And here in Space Bites, we only cover like maybe 5, 6 stories, 10 at the most. But in the newsletter, I cover upwards of 30, sometimes 40 stories that have broken this week in space and astronomy news. So if you want a more complete picture of everything I'm looking at, you should definitely subscribe to this newsletter. The universe could be smaller than we think. So there's two possibilities. Either the universe is infinite or it's finite. So if it's infinite, it just goes on in all directions. So like that makes sense. Now, if it's finite, then it means that it wraps. And sort of think about a game of asteroids where you're going to go off the left side of the screen, you come back on the right, you go the top, you come on the bottom. And if you go about the front, you come from the back. Anyway, wrapping in 3 dimensions isn't something our brains are really designed to think about. So astronomers have tried to figure out what's the case. Like, is the universe infinite or is it finite? And based on all of their measurements, it is at least 400 times bigger than the observable universe. So if you think about the volume of the observable universe, 400 times that. So it's big, but it's not infinite. Like, infinite is infinitely bigger than really big. But a new paper is suggesting that the observable universe is essentially the bare minimum that it has to be. It's no bigger than those lower bounds of the volume of the universe. And their theory suggests that you didn't need that early inflationary period that is required for the kind of the Big Bang cosmology as we understand it today. But it requires additional dimensions. So it's very string theory adjacent. But it's an interesting idea, and like any idea that doesn't require inflation to try and explain the universe that we see today would be helpful, but evidence is required. I'm going to talk about our investment in UAP research, but first I'd like to thank our patrons. Thanks to Mark Anstius, Joel Yancey, Antonio Lofilara, Dustin Cable, Just Paul Davis, Vlad Shiplin, Jay Dennis, David Giltonan, Modso George, Jeremy Mattern, Jordan Young, Tim Whalen, Dave Veribioff, Andrew M. Gross, and Josh Schultz, who support us at the Master of the Universe level, and all our other supporters on Patreon. So the quiet part of the UAP report from NASA was that they recommended that there be additional programs, like they're setting up a new group at NASA with a new director, and they're going to have budget and they're going to have staff, and that they recommend that there should be spacecraft networks and satellites and things like that. Like, this is going to turn into money. And I think for like a lot of people who are mildly interested in UFOs and UAP research, they're like, yeah, like, let's declassify all of the stuff that's out there. Let's let more people look at this. And that sounds great. But if you want to get good data, you're going to need some kind of centralized database that's housing this, that's normalizing all of the information that's coming in that people can report. It's going to require additional instruments to be put on aircraft, spacecraft. And they're suggesting that you could adapt existing satellite networks, or maybe even build new satellite networks. You could build space telescopes that are scanning the atmosphere of Earth, looking for anything that would match some kind of UAP configuration. How much do you want to spend for this? And so like up until this point, it's been purely theoretical. And now as the demand is there, you're seeing it from the Air Force, you're seeing it from the government. People are going to have to set aside budget. Do you want to spend tens of millions of dollars, hundreds of millions of dollars, billions of dollars, tens of billions of dollars? So far, there's been no evidence that any UAP is of extraterrestrial origin. They're unexplained. And so to explain them is going to take money. And I think this is where the rubber is about to hit the road, where people are going to have to decide, how badly do they want this information? How badly do they want to get to the bottom of this mystery? Because it's going to require budget. And so are you willing to pay more taxes? Are you willing to pull budget away from other programs to be able to fund this? How much? How long? How much stomach do we have for this? So it'll be interesting to see moving forward what kind of budgets people are willing to expend on an ongoing basis to get the kind of data that's going to be required to get unambiguous information about UAPs. And I think for most people, no amount of data or information is going to be enough. It's faith. They believe that we are being visited by extraterrestrials, or that other nations on Earth have advanced technologies that we don't have, and that there is some conspiracy covering up disclosure to the rest of the citizens, and there would never be a satisfactory answer. And so the question is, how much do we want to spend trying to provide that satisfactory answer? All right, we'll see you next week.